Here I am going to discuss about mass spectrometry. Mass spectrometry is a technique where molecules and atoms are separated with respect to their masses. So this is one of the most suitable technique for identify different isotopes of elements. I am entering into discussion. Please subscribe my channel. It will grow my interest to prepare more videos in different topics. Mass spectrometry is a technique in which sample is converted to rapidly moving positive ions by electron bombardment and charged particles are separated according to their masses. Here, the element is normally bombarded with high energy electron. When electron will strike element, then the element will be ionized. These ions are normally called parent ion. These parent ions are not stable. It will again produce some fragmented ions, which is normally called fragment ion or daughter ion. All these ions are detected by the detector, and ultimately the detector gives the output with respect to their masses. Here molecules are ionized with high energy electron beam and ions are deflected through a magnetic field. These ions are separated with respect to mass by charge ratio, that is m by z, where z is charge. Now in this case, mainly all the ions are produced which are singly charged, means the value of z is 1. So m by z will be just m. So the ultimate output which we will get, that will be with respect to masses of those particles. In mass spectrometry, it is very sophisticated, requires only few nanomoles of the samples to obtain the characteristics information like structure and molecular weight. Here in this mass spectrometer, it gives the relative abundance of different molecules and atoms. Relative abundance means how much relative amount of different molecules and atoms are there into the sample. This is most suitable for identifying different isotopes. Isotopes are having same number of electrons, they are having same electrical property. So those are not easily detected by different chemical reaction. Mass spectrometer is one of the easiest way to separate and identify isotopes with respect to their masses. As in this case, all the samples are ionized, so this is, we can say, it is destructive in nature, as whatever the sample we use, all the samples are ionized. So if we want to get back the sample, that is not possible. Now what is mass spectrum? Mass spectrum is a plot of relative abundance against the ratio of mass to charge. Here in this case, the x-axis is mass to charge ratio m by z and y-axis is relative abundance in percentage. Now m by z, in this case, whatever the ions are produced, the maximum ions are singly charged, means the value of z is equal to 1. So in x-axis, m by z, which is equal to just m. So whatever the peaks in mass spectrometer will get, that will identify different molecules or different ions with the relative abundance. Next coming principle of mass spectrometry. Here in this case, molecules are bombarded with a beam of energetic electron. By that, molecules are converted to highly energetic positive charge ions. These ions are normally called molecular ion or parent ion. Further, those molecular ion or parent ion breaks up into a smaller ion, which is normally called fragment ion or daughter ion. All these ions, means molecular ion or fragment ion, are separated according to their mass and charge by deflecting in magnetic field. Those ions are normally allowed to pass through a magnetic field, and due to the effect of that magnetic field, all the ions will be deflected due to the presence of magnetic field. Means all the ions are separated. These separated ions are detected by the detector and ultimately analyzed by using mass spectrum. Now mass spectrometry basic steps. These very simple steps. First thing is, it should be ionized, means all the molecules should be ionized. Then the next step is filtration, means all the ions will be filtered. Filtered means all the ions will be separated according to their masses. And last step is the detection. All the masses will be detected by detector, and ultimately detector will produce an output which ultimately gets the mass spectrum, those mass spectrum will give the ultimate indication of different elements, different molecules and atoms. Now simply, what is mass spectrometry? Here first step, the electron strike the molecules. This is the electron bombardment. Due to this electron bombardment, the parental ion and the fragmented ion will be produced. The larger shape is the molecular ion and the smaller shape here indicates the fragmented ion. All the ions are directed through a particular magnetic field. When those will pass through the magnetic field, their path will be deflected, means those ions will be deflected, and ultimately those ions will be separated. Means say all the larger ions will strike at this position, then smaller ion will strike in different position, and ultimately if detector is placed here, here and here, those ions will be detected separately. Now instrumentation aspect of mass spectrometer. The first stage is ion production. So this is ion chamber where ion will be produced. So sample should be entered into the ion chamber. So this is sample inlet. The sample must be in gaseous form. In ion chamber, ion will be produced. How this ion will be produced? Ion will be produced by striking with the electron. So some electron production arrangement should be there. Here electron is produced say by using filament. So filament will produce the electron and that will flow according to this figure in perpendicular direction. So electron flow is in perpendicular direction and sample will allowed to pass in horizontal direction. When the sample will come at this position, then due to the electron strike on sample, it will be ionized. Our interest is only the positive ion. So all the positive ions and free electron will move in rightward direction. Now as the main interest is the positive ion, so positive ion will be accelerated and that will be focused. For that case, here three plates are there. At the left hand side one plate and right hand side two plate. This left hand side plate is termed as positively charged repeller plate and right hand side two plates are negatively charged accelerating and focusing plate. As left hand side is positively charged, this positively charged plate will repel the positive ion in rightward direction. And here the negatively charged plate accelerating and focusing plate. So those plate will attract the positive ion and positive ions will be accelerated towards in rightward direction. Here this is analyzer tube. Whole analyzer tube are normally kept at vacuum. In this case some arrangement is there which will collect the electron and neutral ions. So only the positive ions will be allowed to pass through rightward direction. Now here all the positive ions will be deflected according to their masses. For that one strong magnetic field is used. When the charged ion will be directed through the magnetic field, their path will be deflected. In absence of magnetic field, all the charged ion will go to rightward direction, but in presence of magnetic field, it will be deflected. The angle of deflection will depend on magnetic field strength, charge and the mass of the ion. As in this case, the field strength is constant and charge is normally already told, it is singly charged. So the deflection will mainly depend on mass of the charged particle. Here we can see the different charged particle having different mass will follow different path and ultimately it will be detected by the detector. The detector output will give the record by using recorder as well as it gives the mass spectrum. From that mass spectrum, ultimately different molecules, different atoms are identified. So what are the basic components in mass spectrometer? The first component is the inlet system. Must have the arrangement so that all the samples are in gaseous form. Next is the ionization chamber. The ionization chamber consists of electron production arrangement as well as different charged place for accelerating and focusing positive charged ions. Next is the mass analyzer. The main function of this mass analyzer is to deflect the different ions with respect to their masses. And next part is the detector. There are different detectors are used in this case to detect charged particles. Electron multiplier, Faraday cuff, photographic plates, photomultipliers. These are mostly used detectors used to detect the different ions in mass spectrometer. The vacuum system. This analyzer tube must be filled up with vacuum because charged particles should not be allowed to interact with any other particle. That's why normally the full analyzer tube is kept at vacuum and it is 10 to the minus 5 to 10 to the minus 8 torr. Now, how the deflection will be varied? Which charged particle will have more deflection? Which charged particle will have less deflection? That can be defined by this equation. R is equal to mv divided by b into q, where m is the mass of charged particle, b is the velocity of charged particle, b is the strength of magnetic field, and q is the charge of charged particle, and r is the radius of curvature. If this is the curved path of a charged particle, and if we consider this is a part of circle, so no doubt the circle must have a radius. This was the actual path in rightward direction, straight path. This is one deflected path, this is another deflected path, this is another deflected path. So the formed angle here is the deflection angle. This particle's deflection angle is lower. The middle particles have higher deflection and these particles have highest deflection. So which one is more deflected, that can be defined by the radius of curvature. Now this circle have higher radius of curvature, this circle have lower radius of curvature. So higher radius of curvature means less deflection and lower radius of curvature means higher deflection. So in this case, the magnetic field strength is constant, velocity of charged particle is constant, and q is the charge of charged particle, which is normally considered as singly charged. So this is also a constant. So only variable is the mass of charged particle. Now for the case of higher mass, the r is higher. For the case of lower mass, r is lower. So for higher mass, r is higher. R is higher means say this path. So higher r means less deflection. So which particles are having less deflection? The higher mass. Means the particles having heavier mass will have less deflection, and for lighter mass the r will be less. So the ions which are lighter means mass is less, those ions will have higher deflection. So ions having heavier mass less deflected, ions having lighter mass more deflected. So different ions with different masses will follow different trajectory. Now how ions are detected? One way is by changing the strength of magnetic field. From this equation we can see the radius of curvature can be changed if we change the magnetic field strength. If field strength is higher, then radius of curvature is lower. Radius of curvature is lower means more deflection. So by changing field strength while keeping the detector position constant, we may detect different charged particles. So for this figure, this is having lower magnetic field strength and the deflection of different particles are like this. Higher mass have less deflection and lighter mass have more deflection, and detector is placed here. So this detector is detecting these particles here. If we want to detect the heavier particles, then what we can do, we can just increase the magnetic field. When we will increase the magnetic field, radius of curvature will be reduced. These ions will be closer to the detector. See here, the magnetic field strength has been increased. Now the heavier ions are almost as close as detector, but it is not detected. If we want to detect these ions, the field strength will be increased a little more. Here field strength has been increased. Ultimately the heavier ions are detected by the detector. So by changing the field strength of magnetic field, we can detect the different ions having different masses. Now explaining few example of mass spectrum. This one mass spectrum, we got the peak at mass to charge ratio 18, 17, 16 and 1. When you got this type of peak, one can easily understand that this is related with water particle or water molecules or atoms. Because mass of charged water particle is 18, 2 plus 16. This is base ion or parent ion. Oxygen has two isotopes, one is 16, one is 17. So at 16 and 17 we will got two peak hydrogen ion having mass 1. So when we got peak at 18, 16, 17 and 1, 18 at highest peak and other peaks looks like this. These are the relative abundance of different ions. From this mass spectrum, it is easily understood that the unknown sample was vaporized water. Now this is another mass spectrum. The peaks at 44, another peak is at 28, another peak 16 and 12. So when this type of peaks we got, then easily understood that this is related with carbon dioxide. Carbon dioxide mass is 44, 12 plus 16 into 2. This is base ion, molecular ion. This is the fragmented ion, carbon monoxide 28, oxygen mass 16, carbon mass 12. When we will get peak at 44, 28, 16 and 12, no doubt it is related with carbon dioxide. This is another mass spectrum. Here the peaks are at the value of m by z at 35, 37, 70, 72 and 74. So when this type of peaks in mass spectrum we got, then it is understood that this is related with chlorine, because chlorine's molecule m by z is 74. Chlorine molecule having isotope chlorine 37 and chlorine 35, so m by z is 72. Chlorine molecule formed with chlorine 35, mass is 70. Chlorine isotope Cl 37, mass is 37. This chlorine isotope Cl35, mass m by z is 35. So when we will get peak at value of m by z like 74, 72, 70, 37 and 35, then it is easily understood that unknown sample is related with chlorine. So what we learned from this discussion? We have learned what is mass spectroscopy. It is a technique by which different molecules, atoms, isotopes can be separated with respect to their masses. We have learned the instrumentation aspect of mass spectroscopy. We have learned how to read and analyze mass spectrum. Please subscribe, put comments and queries in comment section.